started recording. I have started recording now. Okay. So what is a Kubernetes here? Okay. So this was originated by Google engineers. Okay. This is a open source project. So always Google, what Google will do, always it will try to give lot of resources free to the end user. So that is why no one can be able to compete with Google, because it will be giving free services to directly to user. Okay. So this Kubernetes, it's like a Linux kernel, like a OS. It's on a distributed system. For a distributed system, so you will be managing lot of stuff, uh, and you will be orchestrating lot of resources also. Okay. So let me put it one in a one diagram here. I will open up. I will open one diagram for you. Okay. Kubernetes. Let's say you are running one service here. Okay. So this is on a physical server. This is on a virtual VM. Okay. And this is on a one more instance. Okay. So you are running a container here. Again here you are running a container. On this container, so you are running a website here. Let's say this is your website. Let me change this color. Okay. So you are running a website here. So this is your website. So let me take a pen here properly, so that it will get neatly. Okay. So this is running on, these are the containers. Okay. So the smallest unit, we call this as pod here. Smallest unit, we will call this as pod in the Kubernetes terminology. So let's say this is going to get crashed here. So you are running here, let's say you are running 3 services. Let's say this container you are running one more container here, container A, container B and container C. Let's say container A is going to get crashed here. Okay. So then it will know Kubernetes, what Kubernetes will do. Okay. So I know what and all services are running. Okay. I will move it into this platform now. Okay. Onto this VM or containers, I am going to move this pod here. So that is how you will be doing it. Okay. So it is loosely coupled for deploying your applications here. Okay. So and let's say you want to maintain a desired state. Okay. You want to run it 3 instances here. 1, A, B, C. Okay, you have instance 1, 2 and 3. Okay, you are running a website. So always 3 should be running. So that is your desired state or application which automatically has to manage it. Okay. So the Kubernetes will be managing this. Okay. It will be moving in and out of these services from one pod to the other one. Okay. Think like, okay, Kubernetes as a ship of the captain. Okay, wheel, you are seeing this wheel, right? If you see that wheel there in the icon, let me open up that icon here. 1 minute. We will type Kubernetes here. So you will see this icon here. Okay, this is your captain's ship, ship's captain who is driving that ship here. Okay, so let's say your container is like a so you are taking a container. We'll go back to again here. Notes here. So your container is you just got one container. Okay. So this is your Docker. Okay, a container. So you have lot of containers here. Like Kubernetes is like a shipping yard, or you can tell as port. So it will be managing the entire port here. So what Kubernetes will be doing, you tell where you want to go. Okay, Kubernetes, like if you want to take an analogy of, you can take it like how you want to steer it. So whether you want to go right or left, all that it is going to adjust that sails here. So if there is a storm coming in, what I have to do? Okay, this it is going to handle that. So what does the Kubernetes do then? Okay, so it will be acting as your Linux distributed kernel here. Let me draw here. This is your distributed kernel here. So kernel means your operating system, let's say. So you have OS here. Okay, just like your Linux operating system, you will have CPU, memory and disk for that particular application. So similarly you will have a underlying cluster of machines here, or nodes. Let's say you have one node here, 2 node, 3 node. Okay, so whenever I call it as a node here, you have to think like node means it is a part of cluster. So we will not call it if it is a server. Let's say if I call it server means a normal computer or a hardware machine. Okay, so physical server means which is a physically located. If I call the same as node, okay, we have a physical node or server node. Node means there is one more server here or one more node. So whenever there are cluster here, then we will call it as node here. So when you call them as node means you have more than one. Okay, you will have two node cluster. Okay, two node. Then I will have three node cluster means I will have three servers. Then I will have n node cluster. Okay, so all will be acting as a single server. That is where we will call that as a node. Okay, so which will be representing your uniform interface. Okay, so whenever you try to run a application, let's say these are on the physical server, let's say this is on physical. Okay, now let's say this is on virtual. Okay, this is on container. Okay, so you want to run the application here. Let's say you are having a Flipkart.com. Okay, you have a website. So you don't care whether your website is running on a physical server, okay, or on a virtual machine or on a container. You don't care. Okay, so you just care like if I open www.flipkart.com, I should get the website. That's it. That's what I want. Okay, so Kubernetes, what it will do, it will manage all these resources here, your CPU, like RAM and disk. Okay, so it will be managing all this here with your physical, virtual and the containers as well. Okay, so if let's say it is you are running it here like physical server, you are running 20 VMs. Okay, and then you are having let's say 80 applications. So let's say this server is going down. Okay, let me bring this down. Okay, so what Kubernetes will do, it will try to move all these 20 VMs to a different server, or it will see how these 8 applications can run it on VMs. Okay, how I can push it. So let's say this is going down. Okay, then it will move here. Okay, so I am going to move. So this is all it will be doing. Okay, Kubernetes turns a fleet of machine into one single and programmable compute fabric. Okay, this is all will be like a single compute fabric. So you can deploy it to any cluster. Let's say I have let's say I have 400 physical servers, let's say. So I am having 400 physical servers. Okay, so then I have 8,000 VMs. Okay, so these are small VMs. Okay, so I have 8,000 VMs. Then I have 20,000 containers. Okay, so this entire, we will call this as compute. Whenever you have CPU and RAM, we call this as compute here, these two. So disk, it will become differently now. Data, it will come as different. Okay, this we will call as data. Okay, so if you combine these two, we will call it as compute here. The entire environment, we will call this as a compute environment. Okay, so you will have a cluster now. Inside this 400, you have a production cluster, development cluster and a staging cluster. So production, let's say you have allocated 80% here. So for testing you are using 5%. Okay. For development you are using 15%. Okay. This is environment how you have shared across all these servers here. Okay. Before K8s, okay, let's say a server is down. Let's say if this server is down, you will not know how to transfer this load here. You will need to see what services. Let's say this is running here 20 VMs. Let's say this is running 20 VMs, and so each VM is running 30 applications. Let's say 30 applications means 600 applications outages you have to face. Okay. So now with K8s, if this server is powering off or having some issue, or it got restarted, so then it will automatically, all these services will be started or restarted into a different server. So it will pick up and it will just simply reschedule all the workloads here. So workloads means, okay, whenever I talk about more than 3 or 4 VMs, then I will call it as workloads. Okay. So if I am talking about a server, then I will tell, okay, whether that is physical or virtual. Okay. If I am talking about a instance, then I will be talking about the cloud VM here. Okay. So whenever I speak on the instance part, then I will be speaking about the cloud terminology. Whenever I tell node, okay, then I am talking about the cluster here, which are the physical servers or cluster nodes, whether it can be VM or physical. Okay. So that whenever there is a terminology here, you need to understand what I am speaking. You need to understand the context also behind that. Okay. So now you have a architecture here. So we have masters and you have node here. So now I don't have to explain what is node here. Okay. So we have masters. So this you will have a two primary building blocks. In Kubernetes you will have major two building blocks. One is your master, the other one is your node here. Okay. So this will be your control plane, okay, where you will be managing everything. Okay. This will have a complete control. Okay. This will be doing all the decisions here. So it will control everything. It will have all the control. So how to schedule, how to respond to events, how to store everything. Let's say you want to take an analogy, then you can take it as a brain. So this is the brain of Kubernetes. If we go by the analogy, then it will be captain's bridge. Okay. Now you have a node here. Okay. This is where your actual server will run or your workload will run. Let's say this is your VM. Okay, they are just controlling. So now this node is where the actual application will run or your workload. Okay, let's say this guy is a captain. This is the crew here. Okay, or your engine room. So this guy will be controlling, and this you will be managing here. Okay. So let's see the diagram here. Okay. So you have here masters here. So where it will be like you are managing everything now. Okay. So here you are having nodes here, your worker nodes, where actual all these services will be running. Okay. So now it will be scheduling what you have to take the decision, how it has to be run. All these decision will be done here. Okay. Everything on your left. Okay. These are the masters, is about the control here, or you can say this is the control plane. Okay. So everything on your right, okay, it is about your execution here. So all that arrows are showing the communication here. Okay. Through your API server. Okay. There are no backdoors. So it is just straightforward. That's how you are going to communicate. So you can ask here, we will see what are the components here. So you have master components. So you have 5 core daemons here. So you know now what is the daemon here. Daemons are, you can think about now it is like a department here. Okay. How the Kubernetes control the plane here. So control plane, then that is your execution plane. So here you have Kubi API server. This is your front door. Front door of the Kubernetes, where it will exposes the API here. This is where it will be the entry point for the for your interaction. So this is the legitimate way to interact with the cluster here. Okay. So here key responsibilities of this Kubi API is, okay, so it will be authentication and then authorization, verifies who you are and what you are allowed to do. Okay. And then it will do a request validation. Okay. When it will ensure that you have a proper YAML file. Okay. You are coming with a proper YAML file or JSON format. So it will check whether the format is correct or your structure is completely valid. It will check for that. Okay. And then it will allow it for the admission here. It will allow whether you are allowed to enter here or I have to deny. Okay. So whether I have to reject it or I have to allow it, what I have to do. So this is your let's say this will be your gatekeeper here. Okay. Nothing will touch it directly except the Kubi API server. Okay. This is very critical for security and consistency. So this one will be managing only by the Kubi API server. Okay. So think like it is a gatekeeper. Okay. So all read and write to the cluster state, it will be going to through the API server only. If something is going wrong or you need to manage, everything control will be done by the KPI, Kubi API server only. Okay. Everything in Kubernetes go through this API server only. Okay. We'll go to here. So you see here everything, whatever you are having node 1, node 2, everything is going through API server only. Okay. So all your nodes, users, controllers, everyone will be queuing at the same door. Okay. So now we have etcd. So this is the daemon. This is the source of truth. Source of truth means single point of information. That we will call it as source of truth. So this is your cluster source of truth. Okay. It will be distributed. Okay, and it will have a consistent value. Okay, so it will be we will see how the information is stored here. So all the cluster state information, like how many you have deployment, configuration, everything, your what is that, authentication means secrets, all it will be stored here. Okay, let me see, someone is calling. Okay, so all you will have all the information here. Okay, how many masters you have, all this it will have a information here. Let's say if you want to know what etcd is, like it is the captain's ship logbook. Okay, why he has taken that decision, every decision, every state change, why you have deviated from the route here, so why the ship is going in this direction. Okay, if there is any if the logbook is lost, let's say if this logbook is lost, the captain doesn't know what the ship is supposed to be doing. Okay, so let's say the captain has made a decision like we are running out of fuel, so I am going to take it to the nearest port now. Okay, that decision he has made it, and he has written it in the logbook, that is it is etcd. Someone has deleted that logbook, someone has lost that etc, and they started taking the route normally. Okay, so in between they will lose their fuel, and they will not able to continue their journey. Okay, so that is why etcd is very critical to maintain the configuration state. Okay, then you have here Kubi control manager here. Somebody call as cube, somebody Kubi, someone cube. So you can call it as cube also, cube control manager. Okay, so this will run all the control here. So it will control manager runs all the core control loops that keeps the cluster healthy. Okay, so let's say I have a cluster here. Okay, 1 minute. So I will take this here. So I am having a master node here, master node 2 and master node 3 here. Okay, so one is controlling all here. Okay, so this master node, okay, so one is taking decision here, it will be checking the health state here. So let's say this is the leader here. Okay, this one is leader. So it will be checking that the cluster is healthy, like 1, 2 and 3. It will watch all the APIs here. You see it here. You have Kubi control, control manager here. Okay, so it will be checking on the APIs, and then it will be checking. You have master nodes here, 1 2 3. Let's say this is not healthy. Okay, so this is having some issues. Let's say these are 3 servers, cluster nodes. If this is not healthy, then it will be flagged it. Okay, this node is having some health issues, means CPU, memory, something like that. So you think it of you have some issues. Okay, and now instead of 2, one will take over as a leader, and it will be acting as a leader, and it will take the complete control. Okay, so example of controller is, so it will take replication controller, ensure that there is a right number of pod replicas exist. Let's say you have these are the worker nodes. Let's say these are connected here to this. Okay. So let's say these are worker nodes. On this you have 120 pods. Means let's say in our terms VM. Okay. So this what it will do in case of failure. Okay, if this node goes down, all these 120 pods needs to be replicated across these 2 nodes here. Whether you do 60/60 or 120, it will ensure that these are right number of pods or replicas exist here. Okay, in case of this goes down, it should be maintaining that. Okay, and it will be managing the node health also. It will be checking all that node health. Okay, so if it finds that this is not having proper health, then it will evict. Okay, evict means it will remove from cluster. Okay, so this is, let's say this got some error here. Okay, this got failed. So now it will evict that, and it will run all that pods here onto the different server or a different node. Okay, now we have control manager. Now we have cloud controller manager. Okay, cloud controller, let's say Kubi control manager. You want to know what Cube control manager will do. These are like a autopilot here. Okay, so they are into autopilot mode. They will continuously observe it, compare, and then they will act. Okay, so the desired state and the actual state. Okay, I will be continuously working 24/7. Okay, let's say the ship should be having some 8,000 liters of fuel. Okay, this should be continuously, I will be continuously monitoring this. If this goes down, okay, so I will have a trigger here. It should load that particular fuel here. Let's say you want to add 12,000 liters capacity. So then it will be adding to that particular engine or to that particular fuel location. So the think like the controllers are the autopilot. Okay, so our desired state is 8,000 liters. Okay, it should not go below that. Okay, whenever it goes down below the 8,000, then it will automatically fill up that fuel. this is what your control manager will be doing. So we have now cloud control manager. Okay. So cloud control manager is now your Kubernetes, you are working it on a local. So this is you are working it on a on premises. Okay. So now you want to run it on a cloud here, whether it is AWS, okay, or you want to run from the GCP, from the Google Cloud, or you want to run from Azure. Okay. So this will bridge the gap between the cloud provider API, okay, and the Kubernetes here. So you are running entire your infrastructure. So this will interact directly with the cloud here. Okay. So controller nodes here includes your controller. It will add specific node metadata here. Okay. So what cloud specific node metadata you want to add, whether it is region. So I want to add a AWS North America region. Okay. So I will be adding that. So I want to do a route controller here. Okay. So I want to configure cloud network routes for pod communication. Let's say, so I have pod here. Let's say I have a pod. So I want to communicate to North America. Okay. So this cloud controller will take it and it will communicate with North America region. Okay. So this is why it will help you with the cloud controller, this configuration. It will help to control all the communication. Okay. Then you have a service controller here in the cloud controller, where it will create a load balancer. Okay. It will create a load balancer for the Kubernetes service type. Okay. Let's say you are having services here. Let me erase this here. Let me take a call. I will get a pop-up and then I will allow him. Okay. This is my recorder. Okay. Yeah, Partha. Yeah, Partha, you are able to see the screen. Let me pass the recording here.
Yes, 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 sir.
Okay. So this is going to create a load balancer also here. Service controller, it will be creating a load balancer here. Okay. Like you have here 3 pods here. Okay, 1, 2, 3. Okay. So it will create a load balancer where it will be sending it to particular server here. Okay, like 1, 2, 3, 4, 5, 6, 7, 8. It will be doing the load balancing as well. Okay, this cloud control manager. Okay, so the same. So you will be separating cloud specific logic. Okay, which will allow Kubernetes core to remain cloud agnostic. So you don't care which cloud you are running. Okay, it will be same. It will be running it on the on premises and it on the cloud. Okay, nothing will change. If you are running some Python code, it will be running it on any cloud, whether you are running it in on premises or whether you are running it on any cloud. Okay, so that is what your cloud control manager will be. Now you have cube scheduler. Okay, so you have the last one here. This is on the master components. Okay, so this one, it will be like, it will be scheduling. It will decide which node a new pod should be running. Okay, so I have a node here. Let me take this. Okay, so I have a node 1 and node 2 and node 3. Okay, so I am running lot of pods here. Okay, so let's say I have one more node here and then I have one more here. Okay, so let's say this goes down here. So I have this is on 70% usage, this is 50, this is 30. Okay, this is 30 and this is 60%. Okay, so this scheduler will decide. Okay, if this goes down, okay, let's say you have 800 pods here. Okay, 800. Scheduler will decide which node a new pod should be running. Okay, so you are going to run one more pod here. So this scheduler will tell, okay, you go and pick up this or this or this. Okay, so scheduling criteria, it will have a request here for CPU and memory. Okay, if you are requiring any GPU card, okay, or any specific OS, do you have any anti-affinity? Sorry. If you have any anti-affinity properties, anti-affinity means, see, you are running one pod here. Okay, and the same cluster you should be not running in this same. Okay, if this goes down, entire pod, entire your service will go down. That is why you should have a anti-affinity here. So if I am running here, let's say I am running one service here, then this same pod should not run on this physical server or on this node. So I will not going to run on this, then I will take either this one or I will take this one or this one. Okay, so this is called your anti-affinity and affinity. Okay, put them put these pods together, that is the affinity. Anti-affinity means keep them apart. Okay, don't keep in the same here. Okay, and then you can specify it, only special pods can run here. Okay, let's say you have dedicated this server to run a critical services. Okay, so scheduler does not start containers. Okay, it is just writes the node name into the fields here. Okay, so we will see that in installation, how it will work like that, then you will get the idea of this. Okay, so we will have one more theory or practical. Tomorrow we'll see it, how we will install the Kubernetes here on your server. Then we'll see what exactly those roles are. Okay, so it will look like, okay, there is a lot of confusion, there are a lot of things that we need to learn, all that. So it is not like that. So this is your node 1, node 2, like that you will have number of. So you have master nodes where this will be managing. So we will see that in one practical. Then you will come to know what the master will be, what the node will be. Okay. So then we'll see you tomorrow. We will connect on the same topic. Okay.
Okay, sir.
Okay. Thank you.
Okay, sir. Thank you, sir.